All right, so here's an example where we're being asked to find the area bound between two curves, and we've got y equals x squared, the parabola, and y equals x cubed, the cubic function. And so the first thing that we need to do is find the area that's trapped between the two curves, and for that we need the intersection points. So if we put them equal to each other, we'll be able to find the values of x for which both graphs have the same y values. And so in this case we have x squared equals x cubed, so we're going to take x cubed minus x squared equals 0, and we're going to factor this down. We have x squared as a common factor, then we have x minus 1 as the leftovers. And so we can see that either x equals 0 or x equals 1 are the roots of this equation. So they're the x values for our intersection points. When x equals 0, y equals 0, and when x equals 1, y equals 1. And so those are the 2 points on the graph where, whoops, it's not a very straight line, where these are going to intersect. So there's 1 and 0 and 0. And so one of the curves, the parabola, looks like that, and then the other one, the y equals x cubed, actually runs along just underneath it, because when you're cubing a number that's less than 1, then you're always multiplying a decimal times a decimal and making it smaller. And so this is the y equals x squared curve, and this is the y equals x cubed curve, and that's important because we need to know which one is the top and which one is the bottom. If we get that wrong, we're just going to get a negative area, so you can go back and fix it afterwards. It's not as much of a big deal as it sounds. So to find the area, we're going to integrate over 0 to 1, and we're going to take x squared minus x cubed as our function, dx. So we're going to find the integral of this function. And so the integral of x squared is x cubed over 3. The integral of x cubed is x to the 4th over 4. We're going to evaluate that over 0 to 1. I'll just work up here so that we don't need to move the screen down. Okay, so all we need to do now is we're going to take what we got and we're going to first sub in 1. So we get 1 cubed over 3 minus 1 to the 4th over 4. I'll put that in a bracket. We'll come back and work that out in a minute. Minus, and now we're going to put in 0 for x, so it's going to give us 0 minus 0 just for the second bracket there. So if I have 1 cubed over 3, that's the same as 1/3. I have 1 to the 4th over 4, that's the same as 1/4. So using 12ths as our common denominator, we end up with 1 over 12 for the area between these two curves.